What is up, everyone, and welcome to the Big Ideas in App Architecture podcast. Today, we have a different episode from our regular, programming, because today I have one of my favorite people in the company at Cockroach Labs coming on to talk to us about some really interesting stuff that he's been working on. And the person on the podcast today, his name is Reid. And before I butcher his introduction, I'll let him talk to you about what he does and who he is. Welcome to the podcast, Rob.
Hi, everyone. I'm Reid. I'm a technical evangelist at Cockroach Labs. And essentially that means I get paid to talk about a database that I already loved long before I joined the company.
Tell the people a little bit, like, what made you fall in love with doing what you do on a day-to-day basis? Was there something when you were growing up you felt like I needed to be a technical evangelist? Or how did you fall into this? Yeah.
There was never a point at which I thought, I'm going to work with databases. I need to work with databases at some point in my life. No, I fell into this role. So I was a customer of CockroachDB for quite a long time. And I developed some really lovely and lasting relationships with the Cockroach Labs team. And before I'd met them, I'd already used the database for personal projects, and I realized the importance of it. So for me, joining a company with whom I shared a lot of respect for the people, and I already loved the technology. I've got a tattoo of it on my body. Yeah. It was a no-brainer. I think I was always going to end up at Cockroach Labs.
Very cool. So is this like a trend that every company you work at, you put a tattoo of that company or
Exactly.
Technologies you love? Okay.
No, I get a tattoo of the company so that they can't say no.
That's really awesome. So what I love about your story, obviously, something that I could relate with myself, is that the whole idea. And okay, for everyone listening, this is going to be a shameless plug about how amazing CockroachDB is. Okay, that's what we're going to be talking about in today's episode. But genuinely, we want to get into some of the things that Rob's worked on to kind of understand why it is so good. But to come back to what, Rob, you were sharing, right, your own story, I could relate a lot with that. So what happened was, about 2 years ago, I was trying to do a personal project, and I was working on Cassandra, which I was using for about 5 years, and I was even part of selling Cassandra for a long time. And I loved the database. I loved the people in the community. Some of the people I just spoke to recently as well, like, things are looking like very interesting on that side. But what happened was, the kind of use case I was working on, I needed scale, obviously, but I also needed consistency, right? Like, data should be consistent, and I needed to do some joins and certain things that, Cassandra couldn't do for me. So I naturally started looking for the answer and ended up at something in CockroachDB. At first, I thought it's like a meme, it's like some meme database or something. I don't know if you're following this. Like, apparently, Redis, which is one of the open source projects that turned into a company, recently somebody made a meme database out of it called Radish. So it's basically called Radish, and I thought initially this probably is a meme database called CockroachDB. So I wasn't really particularly interested in it. But then I started going to Stack Overflow at the time before ChatGPT, right? We would go in and start asking questions. And I ended up at a situation where I would see so many CockroachDB references. I'm like, maybe this is something serious. So I started using it and completely realized that this was what I probably needed for a decade. And I went the NoSQL route, or at least Cassandra route, because that was the only best option. So it's like the story of what we kind of want comes a little later in life, and just have to be patient with it.
And I don't think either of us would want to slight on any of these other databases. I think given the right use case, every database is fantastic. It just so happens that CockroachDB is fantastic for the use cases that we had, and also fantastic for relational transactional workloads that just can't fail. But for other workloads, Cassandra is fantastic.
Yeah, I agree. Yeah. And so how long have you been in tech, been doing this yourself?
So I've been in tech since 2006, professionally at least. I started off by, my passion for tech was ignited when I wrote my first naughty software at college. So, but I mean UK college, not US college. And I wrote a macro into Word, whereby wherever you closed an instance of Word, 2 more instances of Word would open. So I installed it on some of the computers at my college, and then sat back and watched.
That's very cool. I mean, I love that idea that everybody kind of falls into tech. Nobody really.
You're either bitten by the bug or you're not. And I think if you're bitten by the bug, you're bitten hard, and you have a lifelong passion for it.
you were mentioning some of the things that you're working on, some really interesting ideas around the way you look at the architecture, the way customers have been talking to us about why they love CockroachDB. So why don't we get into that a little bit and kind of start from there?
So it all started, this architectural simplification project, back in last year. We were talking with our customers. Our customers were talking actually at an event called Roach Fest, and we have Roach Fest every year. This time it was in New York, but we have it yearly, and now it's on the road. So it's going to be shameless plug. It's going to be in New York, San Francisco, and London this year in June, where our customers come, they talk, they share stories, they share knowledge. It's not just customers. People who are interested in getting to grips with CockroachDB can also learn from the experts, the people who are using it in production workloads. But anyway, there was a theme. Last year's 2023 Roach Fest, there was a theme, and that was one of architectural simplification. So customers aren't just replacing a database or databases with CockroachDB. They're simplifying their architecture as a result of onboarding distributed system into their architecture. And actually, for the majority of our customers as well, that's not just an architectural simplification, but it's an organizational simplification. They can change their engineering organization as a result of a database, which I think as a technology is a huge thing. It's like a massive feather in our cap that we cannot just replace most, if not all, databases. Obviously, depending on the use case. But to simplify an architecture is one thing, but for the organization then to be able to simplify itself after having onboarded us is huge.
I think that's what I've been noticing off late as well. Like some recent conversations that I have had with customers, I'm realizing many of them are trying to modernize, right? And this has been going on for a while. Everybody wants to modernize. They're like, well, we are using old systems. We are trying to get off the mainframe, and then while they get introduced to CockroachDB, the CockroachDB promise is essentially the same promise of, say, a mainframe system that is highly available, fault tolerance, can handle your OLTP transaction. But now it's also catering to this cloud native capability, your application modernization, anything and everything that the company who has been on this old system wants to do. Now you can do it in CockroachDB. And they're like, well, this is good, because they were like, well, I can do like an apples to apples here, obviously, but in a completely new paradigm. So
exactly. And if you're doing a straight apples to apples, you're not necessarily going to get the benefits of a distributed system. I think your mindset needs to change in order to get the most out of the power of the technology that's available to you. And that's what the project is. What we want to achieve with this is to help unlock these simplifications for not only other customers, but for anyone who wants to dip their toes into the warm waters of distributed SQL.
So tell the listeners a little bit and kind of expand that as to why is this part of architectural simplification important for them? Like, is there something that you've experienced in these conversations that you feel can immediately help people?
Being the technical evangelist, I visit conferences. I talk with a lot of people, and of the hundreds and hundreds of people that I've spoken to at various conferences, AWS, GCP, etc., invariably the problem that people are coming to me as someone on the booth with are, I'm trying to solve this problem and my database I'm not able to do it with my database. And that's, I think, symptomatic of using or perhaps even contorting a traditional SQL database. And that might be something like Postgres and MySQL, those kind of databases, maybe Oracle, or even some of the cloud service provider databases, maybe Aurora or DynamoDB. They're using a database that is fairly traditional in the sense that there might be one write node or one single instance of the database, and they're trying to do modern with it. They're trying to write a modern application with this kind of legacy or traditional, maybe it's fairer to say, piece of software, and they're running into issues. Be that the issue of write scaling, they hit a complete ceiling and then they're no longer able to scale for writes, or they're worried about their uptime. They're worried that I have this huge single point of failure, and now I need to somehow remove that risk from my system. And it's really difficult to remove the risk of a single instance or a single point of failure if that piece of software was never designed to be anything more than a single point of failure.
Right. Yeah. And I think that paradigm, those patterns exist in systems. and everybody's like slowly trying to move away, right? Like I think one of the, you talked about organizational simplification that comes with this is that, well, when you have to design for tolerance, you then have to do blue green deployments. And certain, I know so many people who are like on this environment old system, they're like, oh, we'll just create another environment. That means we have replicate all of this data on another system, and then when a failure happens, we make sure we move or repoint the application, and everybody in the organization is running to kind of make it happen. And then you have to do checks and everything to make sure, okay, we are back stable, and then when everything's back, we just flip the switch again.
Well, I've worked in finance over the years, and that's particularly that model of disaster recovery mindset is very prevalent. And there are people hired to think about disaster recovery. So the idea of running typically on-prem, a primary instance of their system, database, applications, the whole stack, and then they're nursing a completely idle secondary infrastructure. Sometimes with replication, I guess we would have to be with replication if you want any chance of surviving an outage. But then, yeah, you, as you say, you need to test the failover and hope that works, and test it as well and hope that it works. But then you need to fail back. And the RPO, the recovery point objective, the amount of data that you lose, has to be factored in both ways.
Exactly. Both ways.
So it's a risky operation. So with distributed SQL, and especially CockroachDB, you don't have to think about your system in terms of disaster recovery, because you've mitigated the disaster from happening in the first place. Now, obviously, this doesn't alleviate the need for, or obviate the need for, backups and things like that. We would always recommend people have backups of their system. But knowing that there are, if you lose a database node, that you're, or, you know, for example, last week, GCP accidentally deleted a customer account in its entirety, like on Friday night. So for the whole weekend, this customer didn't have a GCP account, so they weren't online. They also deleted 40 networks. I don't know if they were for that customer. I'm guessing they were for other customers as well. But, you know, a portion of the internet went dark. If you're running across clouds, that wouldn't have happened. And you can't run a traditional database or a cloud service provider database in multiple clouds. So, you know, it all comes back to, if you need the resilience, and you need true resilience against failure, so disaster prevention mindset, then, you know, you need something like CockroachDB.
And when I was reading that story, I was like completely flabbergasted and fascinated by how did GCP do it, you know. And I know I work with GCP people, you know, like, I mean, I know, I'm like, why did you guys do that? Like, I have to ask them that question. But apparently they were able to recover it because they were multi-cloud, and they had that back.
Okay.
So
okay. Well,
that's what I heard.
but imagine if they hadn't been multi-cloud. And obviously, like we talk about being, the world was monolithic single instance. Then it went to running maybe some parts of your application stack on one cloud, some parts in the other, and that was considered multi-cloud. But now people are slowly moving towards single application, multiple clouds, if they want true resilience. Obviously, it all depends on your risk appetite as an organization. But then these people I speak to at these conferences, it's not just the case of a traditional database in a modern world. It's the idea of solving complex data issues. So things like replication of data, partitioning of data. And I'm not talking about partitioning of a table in place. I'm talking about the geographic partitioning of data, data localization, being able to pin data to solve things like regional or regulatory compliance. You just can't do these things with a traditional database. When I helped onboard CockroachDB at Lush, I didn't want the whole team to have to speak an esoteric database language in order to interact with the database. And I didn't want them to all become DBAs in order to keep the lights on. I wanted like a database backbone, if you will, that you can trust, that will just keep the lights on. You throw data at it and it gives data back consistently, and you don't have to think about it.
The paradigm needs to shift for these enterprises where they understand the wholeness of this change that they're trying to make. And many times what can happen is that there's this narrow vision, and they're like thinking about, oh, I just need to fix this, but they don't realize how those other things that you're trying to do are also included in that. So for example, I remember if we were talking about the, you know, disaster recovery mindset, right? I remember when I was working at like a couple of companies before I was doing databases, we had to have DR days, man. Like we would have to like make sure that, hey, we're going to do DR today and make sure everything is working. And they would do these, and that they were very disruptive in to our regular routine where we are trying to do certain things. So you go away from, well, you're thinking you're doing customer focus, but you're so distracted because but what if you can get away from all of that, right? And that's what you're kind of talking about. And I love that story. I mean, again, data locality is an amazing feature. Let's dive a little bit more into when you talk about the architectural simplification project, and there's just at a high level, what were the main focuses of the project in terms of the ideas that you wanted to drive, like specifically?
So the first thing we did was identify the customer stories because we wanted it to be real world. So I worked on the brief for the project with a bunch of other people, and we identified 6 high level themes. And we didn't want to just throw a bunch of architectural patterns at the wall and see which ones stuck. We identified 6 themes. One was hyper specialized databases, and that is the very specific, or a database that's great at a very specific thing. And that does, you always want to use the best tools for the job. But a side effect of doing that is you end up with more databases than you might otherwise need, all of which need maintenance, all of which might require a specific type of dialogue in which to interact with it. So that's a lot more knowledge that needs to be known within the team. And that's a lot of, then you get into the world of, well, if I write to this database, how long is it before I can then read it from another? And potentially split brain. If you talk to any one of those databases at any time, which is giving you the correct answer? Then we've got failover. So this is the differentiation between the traditional mindset of disaster recovery, primary, secondary kind of infrastructure, and distributed SQL and multi-active with CockroachDB. Then we have the microservice data integration theme of patterns, which is all to do with the flow of data through microservices. Obviously, microservices solves a big problem, and that is, developer productivity. Obviously, some would have reasons against that, but data productivity, being able to work in isolation on something where the data is isolated to that microservice in a bounded context. But there's lots of problems that arise from that and lots of complications. For example, if you're writing to multiple places, you're in the dual write scenario. Or if you're maintaining caches or having to get data or having to make the decision of, do I introduce an aggregator and tightly couple my services, or do I duplicate data and then have to maintain duplicate data? That's where the transactional outbox pattern comes in with CockroachDB and using things like CDC. So that's the next one. The next one we have is caching. So the umbrella under everything of write performance bottlenecks. How do I alleviate read performance bottlenecks on my application? Traditionally, if you had one instance of a database, the solution was a cache. Now, when I was a customer of Cockroach Labs, I asked a question to the sales engineers that I was working with at the time, do I need a cache for CockroachDB? And the answer was, well, no, try it without and scale it when if you hit a wall, you can scale it. You're not locked into that single database mindset anymore. And obviously with caches, then you run into cache incoherence. Is the database saying the same as the cache? Typically, if you're doing dual writes, no. So again, split brain.
Separation. Yeah.
Yeah, exactly. The next one's data warehousing, and that is, we don't recommend CockroachDB as an OLAP, an analytical workload database. If your sole purpose is to generate analytics, CockroachDB might not be the best fit. There are other great databases that you could use instead. OLTP, transactional workloads, perfect. The ideal workload for CockroachDB. But in order to get data to data warehousing systems, you potentially end up with split brain again. You've got a delay between inserting data and being able to generate insights from that data. So for some queries, you can use CockroachDB for those kind of data warehouse workloads. But again, there are examples in the code that one of the outputs of this project is video demonstrations of the before and after scenario, and a bunch of code demos for the before and after. And I talk about the kinds of workloads that you might want to consider for data warehousing, because you run into things like data triplication. If you want to get data from a database like Postgres, for example, but then you want to get it into something like BigQuery in GCP, you might be looking at having all that data, which might be hundreds of terabytes in Postgres, and then duplicating it to something like, well, let's say S3. I don't know where you'd put it into AWS before taking it over to GCP, but let's say you put it in Google's blob storage. before moving it into BigQuery. And that's triplicating the data and triplicating your storage costs in effect. And the final one is, and something that is close to my heart because I've been bitten by this in the past. I've been bitten by all of them, actually, but this one particularly is application silos for data domiciling. So I've worked somewhere whereby we organically grew the system into multiple regions, but in so doing, we had multiple copies of the stack in each location. And that helped to an extent with regional compliance, but the operational headache that introduced was monumental. We had 17 different installations of the same stack, all with different CVEs, all with different versions of the same of the software, of the database, all with different payment provider integrations. You know, there comes a point at which that setup is no longer scalable. And I think fundamentally, I think it's easier as a rule. Rob's rule is it's easier to go from 2 of something to 3 of something than it is to go from 1 of something to 2 of something. And I think that's where CockroachDB really comes into its own, because you can start, if you need to, multi-region. You don't have to start with one region and then develop a second region, because then you need to figure out, well, how do I route to both regions? And you need to build in abstractions in order to make the holistic system make sense. It's like kids. I would argue it's easier to go from 1 kid to 2 kid than it is to go from 0 kids to 1 kid.
To 1 kid, yeah.
And
I don't disagree with that.
and there's translations. If you build your system to be multilingual to start off with, adding a third language is easy because you've done the hard work of making your system multilingual. So that's that last pattern. It's using a system that's been designed to help you run across multiple geographic locations.
Oh yeah, I mean, I loved some of the thought that was put into this when you guys worked on this, and when you worked on it, really is to kind of take into these very impactful things for businesses and look at these patterns to make sure that you are covering, you know, some of the essentials that kind of everybody is trying to get to, right? I mean, it's not like we have not had, you know, planning or architectures for failover regions. It's not about not planning for, you know, data domiciling, but it's for how can you simplify that journey for organizations, right? Like, and especially going into the next decade, you know, we have had databases in the industry for 50, 60 years. And what they do essentially is, to your point, is we store data. They store data, and that story has not changed, but the way you access the data and how you retrieve the data and those patterns and the requirement of the customer experience has changed so much in the last 50 years. So recognizing these 6 patterns that you mentioned is amazing. I'm glad that you worked on that. And actually, honestly, for me personally too, that app silos for data domiciling, that particular pattern is something really interesting, because I feel like that's where a database like CockroachDB shines through, because you are saying, hey, you don't need to manage 17 from your example different stacks, and we don't have to like monitor 17 ecosystems, send data to Prometheus for 17 stacks, switch between tabs, and monitor if everything is up and running. You just have to monitor one cluster of CockroachDB that manages 17 regions or 17
and
use
that's
cases.
That's a real hidden benefit of CockroachDB. It's the organizational simplification that it's going to give you is so profound that it is the difference between needing to geographically distribute your team in order to manage a very disparate system to being able to centralize the management of an inherently distributed system. You're managing a global thing from one place. And obviously, like, the needs of every organization are going to be different. But from the customers I've spoken to, from the people I've spoken to at events, 9 times out of 10, their aspirations are to scale. You don't start a company wishing to only serve your neighborhood. You have ambitions to go wider. And typically that does involve, 9 times out of 10, crossing borders. And that regulatory compliance has never been more stringent. I wouldn't want to be a data privacy specialist. Well, it might be, it will probably be amazing now, but the complexity of it, it's a science in and of itself. I think there's 140 GDPR-like regulations around the world. And that's not to mention inter-country regulations like the Federal Wire Act, which is one of the reasons one of our customers is using CockroachDB, because it allows them to pin data to different states.
This is only going to get more complex, right? Like with a lot of things happening with AI and we want to secure our data as much as possible, right? And I'm seeing more and more data privacy rules coming up, more policies coming. I've been hearing that India is working on one too, like where they're
LP, what's it
yeah.
called? Yeah, it's got a
I
four-letter
don't remember
acronym.
the name. Yeah. So I did read about it, that India wants to work on a policy like that to keep India's data there. Obviously, like China is anyways not sending anything out or in. It's just natural for the world to get to that point. But then they want to still serve customers across the globe, because that's where true scale and revenue is kind of hidden for everyone, is across borders, right? So that kind of happens too.
Going back to one of the big ideas you held a little while ago with Joshua Prisman, an architect, he made it, I think he hits the nail on the head, because he talks about architecture as being not just the applications that you run within it, but the holistic. So you've got to think of regulations as being part of your architecture, because it's in effect, it's your responsibility to your customers to keep their data secure and to adhere to those complex geographic regulations.
Agreed.
So bringing it in and being able to solve for it from within your own architecture is huge.
You've obviously spent a lot of time trying to identify these patterns and talk about the before and after. Where can people actually go and start reading what you have put together, so they can actually kind of make these changes themselves within their organizations?
So there's github.com, which is available via github.com/CockroachDB/architectural simplification. That's where all of the before and after code exists. I think there's about 12,500 lines of code dedicated to showing you the before and after. You can run it all locally on your computer. You might, in some cases, use local stack to spin up a simulated local AWS environment. It goes to that kind of level. There's also a YouTube playlist with, I think, 13 different videos. I can't remember the URL off the top of my head because it's about 255 characters. But there's a YouTube playlist with all of the patterns before and after. You get to watch me absolutely suffer trying to horizontally scale a Postgres database. Anecdotally, I've always said, oh yeah, Postgres is really difficult to horizontally scale, because I've heard that it is. But as a result of this project, I was able to try and horizontally scale it myself.
Experience it in real. Yeah.
I did, and it was so much harder than I was expecting. So it made me really glad for Cockroach. And the third thing is a webinar. I did a webinar with an amazing architect. His name is Scott Traver, and he works at Spreedly. And he worked with the Spreedly team to simplify their architecture and the patterns that they were using in advent of their adoption of CockroachDB. So we talk about their journey to simplification in that webinar.
Right.
So there's a bunch of different places, but we've also got a landing page. So if you go to cockroachlabs.com/architectural simplification, you'll also be able to get a load of information on simplification patterns there.
So what we're going to do for the listeners is we're going to tag all of that in the episode, and even when we send the information out for people to kind of tag. I mean, this is some really amazing work that you have done, Rob. Like I really appreciate the amount of thought that goes into looking at problems, but not necessarily just your problems. You're looking at the world's problems and what people are working on from experience, going into everything, condense everything into like a white paper or a document or videos. It takes a lot of work, and I'm glad that somebody like you has put that effort in, and that's going to help all the customers and users of CockroachDB, right?
And hopefully non-users as well, because I think before I knew about CockroachDB, I wasn't even asking the kinds of questions that would have enabled the company that I was at the time, because I was thinking locally. I was thinking a traditional database. I wasn't thinking in terms of distributed SQL and the problems that could solve for me. For example, when I was working at Lush, I'd never thought to ask the question, how many bath bombs do I have on this shelf, in this store, on this floor? Then asking, how many bath bombs do I have in this region of the country? How many bath bombs do I have in this country? How many bath bombs do I have of this type in the world? And being able to answer that instantaneously from one place, it allowed me to then start asking different questions of the data. It showed me the art of the possible.
Right. And this was kind of segues into one of my questions that I was going to ask is that what have you learned in this process? What is it that people can learn from keeping their architecture simple, right? And you hit one really good point. Like once you have the framework, once you have laid it out correctly, then that allows you to have the freedom to do so much more, right? So yeah, expand on that a bit.
So the learnings, well, I learned that scaling Postgres was hard. That was my most painful learning. I didn't know personally that we were simplifying architecture before I joined this project for so many people. I think knowing that we were simplifying architecture was one thing, and then learning that we were solving the challenge of simplifying organizations on top of that, I had no idea because I didn't have the visibility into it because I wasn't thinking about it. Knowing that, and when I talk about organizational simplification, I'm talking about things like, given CockroachDB's resilience against failure, you move from having to think about disaster in terms of I need a backup database to the database I have is inherently resilient. And kind of weirdly, that makes it cheaper to run because, and if I were to tell you that running a database across 3 data centers is cheaper than running that same database across 2, like previously, I would have said, well, no, that's not math. That's maths. But actually, it is, because if you're running one database, you need to be able to satisfy 100% of the workload on that one instance, and then you have to have an idle database that's capable of satisfying 100% of the work in the event that database goes away. So that's 2 times 100%. Whereas if you're running CockroachDB, each node is satisfying 33.3% of the workload. So you can have 3 smaller instances of the same thing. So I've learned that, it can be cheaper. You think about distributed SQL and running across multiple places as being potentially more expensive, but it's really not. And then you couple that with the simplification it gives you, the ability to not have to write your own CDC integrations, the ability to pump changes directly from CockroachDB into Google PubSub, S3, Kafka, simply because it's been built in. That's code you don't have to write. Spreedly removed 3 of their own code bases that maintained the what they would call the data cycle that they had in their system. So that was less code for them to maintain. And they also removed databases. They removed the databases that they had in place. They removed the code. They removed the data cycle. They removed a lot of their architecture simply because they no longer needed it. So I think the cost implications of Cockroach, the positive cost implications, were also kind of transparent to me, were kind of opaque to me because I wasn't thinking about it. Yeah, exactly. So, and then there's a lot of patterns that people solve for. For example, you think about dual writes. That typically, if you ask someone who's familiar with Oracle, how do I solve for dual writes? They might think of XA or distributed transactions. When you're dealing with a distributed database that manages transactions in a distributed fashion, you don't need to worry about that anymore. Or, you can pump messages out by way of CDC through a transactional outbox. There's lots of different ways you can achieve the same thing you would have with, by buying an Oracle bolt-on for millions of pounds.
One of the things I remembered when you were saying this is a story of one of our customers. We're talking about dual writes. It was that they decided to test CockroachDB for one of their complex workloads that affects their customers. What was happening was they were writing to Oracle and they were writing to CockroachDB. And during one of their most important events, and again, transactions were running, and the Oracle stack, there was a network outage or something happened that affected the Oracle stack. Basically, Oracle went down. However, CockroachDB stayed on, and there was no issues. And they were like, "What? This is completely like." For them, this was a big revelation that when they changed the architecture to serve the customer experience in this way, there is a big transformation across the overall experience as well. So I felt like that's the time when I was talking to the customer. They said like that's when they decided that they needed to move everything to CockroachDB and stop using Oracle. And again, Oracle has been in the space for a while and did some amazing things, but I think just where the industry is going and the position where these companies who are building these new experiences for customers are requires like a new thought process to how they architect everything, right? So yeah.
And to go
So
back
go
to what
ahead.
you
Yeah.
said before, you mentioned that you have to test fail over and fail back. One of our customers, they have a team, they do game days, as a lot of big organizations should. And for the team that look after CockroachDB, it's a day off, essentially, because they've been unable to take the thing down.
That's good for our support. No, I love that. I love that story. I mean, but there are so many stories like that, right? Like the more I talk to customers, the more I realize this is one really good point that you brought up. This profound uh, understanding that I also didn't have when I started using CockroachDB is that we're not just the database, right? We're not solving the database problem. We're also changing the organizational problem. Like we are solving a much bigger problem for you, a organization. Uh, and that's what this architectural simplification project helps people understand. I'm glad that you also mentioned that it can help people who are not moving to CockroachDB, just the idea of where they can be from where they are.
And especially when you're calculating the total cost of ownership for any system, if you can take into consideration the fact that yes, I'll be able to replace this database. Like even if let's say you're replacing Postgres with CockroachDB because you need the additional scale, just for sake of argument, you'd look at Cockroach and think, well, I didn't need to pay for Postgres, but actually you were paying for Postgres in terms of having to operate it. You were having to pay people who knew Postgres to scale it for you and to keep those lights on. You've got hidden cost that you're paying for. So you've got, yes, there's CapEx involved in the onboarding of any new paid for service, but there's also the OpEx that's going to be drastically reduced because of that.
CockroachDB, it's not for every use case in the world, right? Like there are certain use cases where you might not need to use CockroachDB. But again, knowing these 6 patterns, and if this is what you're trying to achieve, and of course there are more, then I feel like CockroachDB is a great database for consideration. And I think if anybody can take that back, uh, I would say that's what you wanted. Like these 6 things that Drop kind of talked about or brought up is what you're thinking about, then there is an ideal scenario for you to go and check these material out and see if you can get like a free support day in your life.
I was on a customer call a while back. They weren't a customer at the time, but the idea was that hopefully they would become a customer. We drew out their architecture on this whiteboard. So we drew out their architecture, and then we thought, how can CockroachDB help? And I was able to circle things that could simply be forgotten about. You didn't need to, they were of no longer a concern for that company. And I think it was a really powerful learning for them because they could see objectively where CockroachDB could help.
Right. I mean, that's the benefit, right? Like there are so many things that we can get into where the same idea is kind of getting repeated. So much so that you're going to be making a new video on patterns from conversations,
And the white paper you mentioned, I would love to do that. And maybe a book. So I think there's a lot of material here that needs to be shared.
I think a book would be definitely helpful. I mean, I would always encourage people, if you, and especially with somebody who's done so much work on a particular topic, put it out there. Like it's going to be really, really helpful. You brought up the idea of that last part where you talked about ETL. I think our CDC, the way it is, has come a long way, right? Like there are so many new things that you can do. I recently, I think because you mentioned it, I'm going to mention it now. Recently, we've worked on some really cool integrations where you can push data from CDC. And one of my teammates in the team, Harsh, has worked on integrating data from CockroachDB all the way to BigQuery through PubSub. That's one route that you can take. If you're on AWS, AWS recently released during reInvent a feature called continuous ingestion. So what that means is if you can send data to S3, but again, it creates a problem of triplication of data. It's like
Sometimes it's unavoidable. Sometimes, like S3, a great product, and it's the gateway to a lot of the value that AWS provides from a data perspective.
I agree, and you get it to S3, and then from S3 you can directly send the data to Redshift, but it happens in a continuous ingestion way. Of course, there are certain challenges with it because of the pre-processing that needs to be done before it gets into Redshift has to be planned for. But again, it still works. Like that route still works, right? And there is Kafka and MSK and a bunch of those things. So those are important paradigms, right? Because to your point, like I want to know how many bot bombs are there in this country and what types and everything. And you really get into, once you have the data available, to go in and start talking about what story you want to tell with that data, right? And
Yeah, and it comes down to the data warehousing theme of patterns, because it's all to do with minimizing the amount of time from getting the data or updating the data and seeing the value from that data, being able to get and derive insights from that data. And if you're operating against one database, that value is immediate. You can get it straight away.
Well, it's been amazing talking to you, Rob. So before I let everyone go, I usually ask them these two questions. So you have no choice but to answer it. Is that, how do you keep up? How do you keep up with all the madness in the tech space? Like obviously, as a tech evangelist, you need to know what you're talking about. That's CockroachDB, but then all of these other things that people come and ask you, that you're like, oh damn, I didn't know about that particular thing. So how do you keep up? So what's your method?
In terms of news, I use Feedly. And this sounds like now we're going to go into a paid segment from Feedly. I use Feedly because I'm too lazy to keep going to all of these different sources. So Ars Technica and the Verge and the Register all comes to me. So I'm lazy like that. But I think trying to be overly helpful within CockroachDB also benefits me, because I'm having to learn a lot more than I otherwise would if I was just to sit back and be a technical evangelist. If I was just to sit back and write demos and record videos, I wouldn't learn half as much as I do now. So being curious about what other people are doing in the organization and wanting to help forces me into learning a bit more about their role and a bit more about what they're working on in terms of the data space. Is great because it forces me to learn.
Where can people follow you, and know what you're working on?
So there are probably three places I'd say. There's GitHub, github.com/coding concepts. That's me. I work on a lot of open source projects in my spare time, like tools that kind of surround the CockroachDB ecosystem in terms of generating data, inserting data, data-y things. There's also LinkedIn, where I am Rob-Reid, R-E-I-D. And there's also Twitter, where I am RobReid_IO.
It was great having you on, Rob, and to the listeners, it's really amazing to see people come in and get these feedbacks from how you have learned through the Big Ideas in App Architecture podcast. If there is anything that you're curious about, anything that you would like us to get into, hit us up on LinkedIn and tell us what kind of topics you would like us to get into with Rob specifically, because Rob's a tech evangelist, so we can always keep having him come back, and we can see his dog as well as his whiteboard as we get into this. And that's only for people who are watching the video on YouTube. But nevertheless, Rob, it's been amazing having you on. Thank you so much.
Thank you so much. Take care.